So hello guys, with the name of God Ram Ram, we have to solve this problem which was asked in Amazon online assessment in March 2025 for 50 LPA. The CTC was 50 LPA. Also congratulations to our student. He was from Tier 3 Tier 4 college. Then also he managed to crack off campus offer from Amazon. Student Dev Madan. He did it, okay? He was struggling since 1.5 year off campus. Tier 3, Tier 4 college students face so many difficulties. He was also facing. But we gave him daily life training and we always kept him motivated. So he has cracked off campus offer from Amazon despite not being from top Tier 1, Tier 2 colleges. So congratulations to Dev Madan and posting its link also. Now let's see how can we also become like Dev Madan. What do we need to do? I remember Dev Madan has attended 300 plus sessions of mine. How many OACP sessions you have attended? 300 plus. Do you also have the strength to daily come and attend these many of my sessions? If yes, you will also get what Dev Madan got. So it all depends on the effort, okay? So guys, this problem was asked, right? So whenever you are trying to solve any online assessment problem, please always remember that they will give you these big paragraphs and big story and they will try to confuse you. Actual question might not be that difficult, but they will try to confuse you. So always start everything with the name of God, Ram Ram. And the next thing is that always have two skills handy with you, because we are programmers. We will start with zero based indexing. Please have good English comprehension skills. Very important. English comprehension skills, you need them. If you don't have good English comprehension skills, ECS, Amazon Cloud ECS stack. Anyways, you should not fear in reading big paragraphs and summarizing it in 1 to 2 lines, because you have to do it when you give the Fangam online assessment. You have to analyze the big paragraphs comprehension, convert it into 1 to 2 lines, understand it properly, and then whatever 1 to 2 lines you have converted the big paragraph to, you have to solve that hard unseen DSA problem. How to solve the hard unseen DSA problem? Very simple. Come in my daily life training and complete the 850-hour DSA plus OA plus CP course, and that will make sure you crack all type of companies no matter what is your final goal. Okay, so this thing is the best thing and for you, and it is updated as per 2025 trends. Okay, so guys, if we try to read the question, you guys can see it's a very big question. You can try to read and make sense of it, but I will try to give the understanding part in a much easier manner. Okay, you can check the pics also. Okay, so if I go below, below, and let me remove the DD. Okay, if I go below, let's talk about the understanding, right? So yeah, so guys, they are saying that you are given an array of all positive integers. Okay, you are given an array of all positive integers. You are given an array of all positive, or I think the integers whose all the values are greater than equal to 0. Okay, given an array of integers which are greater than equal to 0. Okay, or you can say given an array of size n, find out all indices which are good. Find out all indices which are good. Now what is the meaning of the good index? Good index, it's a very simple thing, guys. Good index means that, see, such difficult the question is, but I am trying to explain you in an easy manner. Good index is nothing but index which can complete the fight and be alive till the end. Now what is the fight? I will tell you. Assuming the index did the fight optimally in best way. So guys, that's it. Now how the fight is happening and what fight is happening, I will explain you. You don't worry, you just relax. Kumar Kesar is there for you, just relax. Given an array of size n, you have to output all the indices in ascending order which can win a fight. What fight? I will explain you. So guys, I am giving you the emoji option. React with emoji if everyone has understood what is the question. The question is that you are given an array of size, and obviously all the numbers in the array will be from the range 0 to 10 raised to 9. That's commonsensical here. But you have to tell me which indices can win the fight. This is not an easy question. Okay, this is not an easy question. Please know that in advance. Be ready for some struggle here. Okay. So guys, what is the meaning of a fight? So guys, randomly now, in each step, what can happen is that any two indices can start fighting. Who will win? The indice having larger value. Like if A of I and A of J are fighting, who will win the fight? The index whose value is bigger. The content whose content is bigger. For example, lovely people, let's say this is the array. There are many indices, okay? This is index 1, index 2, index 3, index 4. Guys, the fight is happening between index 1 and index 4. Can you guys tell me who is going to win? Who is going to win? This is array B. So fight is happening between B of 1 and B of 4. B of 1 and B of 4. This is B array. So whose value is bigger? B1 or B4? B4. So B4 wins the fight, man. Wins the fight. But guys, after winning, it is not over. You will kill it. जान से मार दो इसको. So you remove this one, you make this value as 0. And this one will get added here. This will become 6. Guys, अभी आपको समझा? If there is an I, there is a J, there is an I, and I decides I wins over J, what will happen? Here the value will become A of I plus A of J. It will take all the power of this and this will become 0, bro. So guys, this process will keep on happening until only one guy is left. And if both the values are equal, then anyone can win randomly. Okay, your choice. This process will happen until one guy is left. You have to tell, can your current index be the last man standing? Can your current index be the last man standing? Yes or no? Yes or no? Yes or no? So guys, for each index, you have to tell is that can this guy be the last man standing if the fight happens optimally? Okay. So let's try guys. We can do it. We can do it. We have Kumar ke power. Guys, index 3. Tell me, can index 3, can you arrange the fights in such a manner that index number 3 is the last man standing? You are McMahon. Now you are the director of WWE. You have to arrange the fight such that John Cena only wins in the end. So guys, use your brain and tell me, you are WWE CEO. Arrange all the fights in such a manner such that John Cena or index number 3 wins in the end. तो पहले किसकी लड़ाई कराओगे? लिखो गूगल चैट में, विच पहले कौन से पैर की लड़ाई कराएंगे आप? 3, 2, 1 स्टार्ट. ऑल ब्रिलियंट इंटेलिजेंट पीपल, बताइए पहले किसकी लड़ाई कराई जाए? मेक श्योर करना लास्ट में यही बंदा जीतना चाहिए सब लड़ाइयों में. 3 and 2, 3 and 2, 3 and 2. तो चलो जैसे बच्चे बोलते कर देते हैं. इंडेक्स 3 इंडेक्स 2 का लड़ाई कराइए. So guys, what will happen after this fight? Well, this guy's value is 3, this is 2, I will win over it, this is become 2. And here 3 plus 2, 5. Guys, see, you can see, I have become bigger. I have become bigger, I have become 5, wow. So guys, after 2, 3 fight, tell me, which should be the next fight? लड़ाई जो भी हो, मैं नहीं हारना चाहिए. मैं लास्ट में मैं बचूंगा, बाकी सब 0 हो जाएंगे तो ही मजा आएगा. समझे? अब बताइए कौन सा लड़ाई करे? 3 को 4 से भिड़ा दे कि पहले 3 को 1 से भिड़ाए? Write your observations in the Google chat. 3 should now fight which guy? 3 should be the last man standing. 3 should fight with 1, right? Yes, congratulations. Great job. So next fight is 1 comma 3 guys. Congratulations. So what will happen? Can anyone tell me how the array will look like after 1 comma 3 fight? Currently it is looking like 2055. मैं जाऊंगा लड़ूंगा इसको हरा दूंगा तो ये 0 बन जाएगा इसका 2 मेरे में आ जाएगा. तो guys, I'm opening the Google chat. You guys have to tell me how the array will look like after the fight is over, guys. Okay. Sorry, after the 1 comma 3 fight is done. So guys, tell me in the Google chat, what do you think? 0075. Congratulations, Rui. Congratulations. Congratulations emojis for Rui. She gave such a tough answer. Congratulations. 0075. It was not tough, but still. First. She gave the answer first. 0075. Guys, you want this third index to win, huh? अभी इसको जिताने के लिए फाइनल फाइट कौन सी कराओगे? बेसिकली अपन को क्या करना है ना, जो इंडेक्स 3 है ना वो जिंदा रहना चाहिए, बाकी सब 0 हो जाने चाहिए. समझे बात को? यही बात है. तो बताइए आप क्या करोगे? What fight will you do? In between which indices? Start writing the answer in the Google chat. You guys know what should be the fight. You are WWE CEO, co-founder, creator. 1 comma 3 is the wrong answer, Minal Nunje. 3 comma 4, 3 comma 4. Now we will make the fight between 3 and 4, 7 and 5. So if you do the fight between 3 and 4, what will happen? 7 will win. 0 comma 0 comma 7 plus 5 12 comma 0. Correct. All have become 0. I am the last man standing. Yes, you can say index 3 is a good index. It can be the last man standing if you decide an optimal way. If you decide optimal way to keep it alive. Now guys, everyone has to write yes in the Google chat if everyone thinks that they have understood the question, okay? So finally all you have to do is print all good indices in ascending order. And there is one more example, okay? Like 16272, right? 16272. 16272. Okay, so guys, now we can quickly solve it, okay? Because now you guys understood the question, right? Everyone write yes in the Google chat multiple times indicating that they have understood the question. For each index, they have to check if it can be a last man standing. So guys, here there is Kumar K sir explaining you nicely, but in the OA, Kumar K voice will not be there. So you have to read this question and understand, this is what they were trying to say. So always have faith in God. Clear? So now, let's do the next step. 16272. 16272. Well. Okay. Index 1, 2, 3, 4, 5. Guys, do you think index 1 can ever be a last man standing? No. Even if you make it fight with the smallest guy, it will just lose here only. ये तो भाई पहले में ही हार गया भाई. ये इससे नहीं होना. तुमसे ना हो पाएगा. Okay guys. Everyone write yes in the Google chat if they think that index 1 can never be the winner, can never be the last man standing, no matter how optimally you arrange the fights. भगवान तुम्हारी कितनी भी मदद कर दे, अगर तुम इसके जैसा हो ना तो तुम नहीं जीत पाओगे बेटा. इसलिए बोलता हूं पढ़ाई करो बैठ के. क्लियर? या. सो कैन दिस गाय विन? कैन 6 विन? यस. क्या करूंगा मैं? 6 का लड़ाई कराऊंगा 1 से, 6 का लड़ाई करूंगा 2 से, फिर 6 का लड़ाई करूंगा 2 से, तो कितना हो जाएगा? 6 7 8 9 10 11. ये 11 बन जाएगा. 11 7 को मार देगा. खत्म. Can you feel it? 6 will first fight 1, then 2, 2, 2 in ascending order, greedy algorithm, right? You can feel it. I can also feel it. So yes, he can do. Can 2 do something? चलो देखते हैं. ये 2 आया, ये पहले 1 को करेगा, 3 बनेगा. ठीक है. फिर ये 3 बनने के बाद इसको जाएगा, ये 5 बनेगा. पर 5 बनने के बाद 6 को नहीं हरा पाएगा ना, 7 को नहीं हरा पाएगा. तो आपसे ना हो पाएगा, आपसे भी ना हो पाएगा. 7, guys, you don't even need to check the answer for 7. Can anyone tell why we don't even need to check the answer for 7? I will open the Google chat. Some intelligent person has to tell me why for 7 you don't need to check any process. Write the answer in the Google chat. 7 के लिए कुछ प्रोसेस क्यों नहीं देखना पड़ रहा बेटा जी? It is the biggest element in the array. Largest element in the array. जो array में सबसे बड़ा है, अरे वो तो किसको भी मारेगा, उसे दूसरा बंदा छोटा ही होगा ना, तो वो छोटे बंदे का वैल्यू इसमें जाएगा, ये और बड़ा हो जाएगा, बाकी कोई इसको बीट ही नहीं कर पाएगा, ये हमेशा जीतेगा लास्ट मैन स्टैंड, इसको चेक ही नहीं करना चाहिए. दिस इज द फर्स्ट ऑब्जर्वेशन, दैट द लार्जेस्ट एलिमेंट ऑफ द अरे इज बाय डिफॉल्ट अ गुड इंडेक्स. So guys, the first observation and the analysis is that largest element of the array is always good index. This is the first greedy observation which we are doing, is how do we decide the optimal way for index I to win. Guys, if you're able to decide the optimal way for index I to win, then you can know na if index I is good or not, and we will apply this algorithm on all the indices to get the job done. Everyone write yes in the Google chat if everyone agrees that we need to find some optimal way to check if index I can win or not. Okay, so guys, what is the first observation when the array is given to you? In this you can see there is some greedy thing going on. Okay, observations are coming, max and min. For better visualization, sort the array. Then all the elements on the left hand side are smaller than b of I, so they will become 0 and all of them will be added to b of I. So guys, did you get this brilliant observation which I'm trying to show you? What I'm trying to show you, lovely people, is that if I sort the array 2, 3, 4, 5, 6, 7, 8. Let's say, okay, I sorted. This is my index I under consideration. So guys, one thing I know that all the people, if I sort the array, I know that these guys are lesser than me. So all the people of the left side, I know that whenever they fight my phi, they are gonna lose only, man. 0, 0, 0. And the sum of all the left elements will be added to my phi. So 5 plus 2 plus 3 plus 4. You can maintain the sum of all the elements of the left hand side just maintaining prefix sum. Okay, so guys, the sum will become what? Updated sum will be 5 plus 2 plus 3 plus 4. Let's call it as the updated sum. Updated sum. Earlier the sum was 5. Now the updated sum is 5 plus 2 plus 3 plus 4. Then what you will do? Then sir, I will check, can this value fight 6? If yes, I will add the 6 value to this. Can this updated value fight 7? If yes, I will add. Can this value fight 8? Then yes. Guys, this is the greedy algorithm to check whether index I is good enough or not. Do you understand the plan, guys? ट्रिक क्या है? ट्रिक क्या है? मेरे को जानना है कि ये मेरा जो इंडेक्स 5 है ना, ये पूरा बैटल जीत सकता है कि नहीं जीत सकता. तो क्या करोगे? सर, द फर्स्ट कॉमन सेंसिकल थिंग इज दैट all the left elements, they will always lose. They will always become 0. They are less than 5. So 5 plus 2, 5 plus 3 plus 4. You will add them like this. Now this is your new sum, updated sum or new sum, whatever you want to call it. Let's call it as y. Now guys, to win the game, y has to defeat all these guys also. Got it? But guys, the question comes कि y की लड़ाई आप किससे कराओगे? This is the greedy algorithm I want to ask you. When you get the updated sum, y का लड़ाई 6 से कराए, 7 से कराए कि 8 से कराए? पहले किससे कराए? This is how your brain grows when you do non-standard problems. So updated sum will be what? Updated sum, or y value will be what? It will be b of I plus all the elements which are lesser, because we have sorted the array na till b of 1. Now we should arrange the fight of y comma b of I plus 1. This is the main analysis which most people were not able to do in the exam. बात यह है कि जब सम आ जाता है ना, तो ज्यादा उड़ने की जरूरत नहीं है. पहले आपको हमेशा देखो, तुमको पता है, तुमको अपडेटेड सम तुम्हारा क्या आया, 5 + 2 + 3 + 4, ये मेरा वैल्यू बड़ा हो गया राइट, 5 + 8 9 10 14 राइट। अब ये 14 की लड़ाई में पहले 6 से कराऊं, 7 से कराऊं, 8 से कराऊं, वॉट एवर 14 आई हैव गॉट, आई शुड मेक इट फाइट विद विच नंबर गाइस, स्मॉलेस्ट नंबर इन द लेफ्ट ओवर नंबर और द बिगेस्ट नंबर। क्या लगता है आपको? राइट द आंसर इन द गूगल चैट। किससे लड़ाई कराना चाहिए 14 का? कोई भी नंबर हो, किससे लड़ाई कराना चाहिए? स्मॉलेस्ट। कैन एनीवन टेल मी व्हाट इज द रीजन? व्हाट इज द रीजन गाइस? Reason is greedy algorithm. You will make the choice which is best for current scenario and also best for future scenario. Locally optimal is global optimum. जो सबसे छोटा है ना, उसको हराने के चांसेस ज्यादा है, बट अच्छी बात क्या है, उसको हराने के बाद वो वैल्यू मेरे में ऐड हो जाएगा, मैं खुद भी बड़ा हो जाऊंगा, तो और चांसेस होंगे कि मैं फ्यूचर में बड़े वाले को हरा सकूं। समझे बात को? What I'm trying to say is, let's say in this case only, in this array, instead of 6 7 8 na, let's say there was 6 and 15, there was 6 and 15, so first your 5 added all the smaller numbers, it became 14। अब तुम हवे में उड़ने लग गए, तुम सीधे 14 को 15 से भिड़ाने लग गए, तो लग जाएगी ना। इसी की जगह अगर 14 पहले छोटे नंबर से मिला होता, 14 और 6 20 हुआ होता, फिर 15 को आराम से मारता ना। Everyone write feeling in the Google chat if they can feel that whatever is your updated sum or y value, now whatever are the remaining numbers on the right hand side, you should start the fight with the smallest number, because there are highest chances of you defeating the smallest number. And the next thing is that when you defeat the smallest number, you get its sum as well, which further increases your probability to beat even bigger numbers. But if you start from the largest number, man, you might fail. Okay, so this is a greedy analysis going on. Okay, 6 की जगह 15 क्या? अब 6 की जगह 15 रहेगा तो कुछ नहीं हो जाएगा ना, तो तुम्हारा प्रोसेस हो गया, नहीं हो रहा प्रोसेस, बैठ के रहो फिर। Instead of after 5 there were 215, then you cannot do anything because you have exhausted all your options. This is the best greedy algorithm guys. What is the best greedy algorithm? Whatever your current number is, सबसे पहले मैं what can I do without any harm, हम वो कौन सी चीज कर सकते हैं बिना कोई नुकसान के, पहले हमेशा वो सोचो। बिना नुकसान के मैं सिर्फ एक ही चीज कर सकता हूँ, ये जो मेरा नंबर है ना, जितने भी छोटे नंबर है उनको खत्म करो, उनका सम अपने अंदर ऐड करो, और कुछ कर नहीं सकता मैं। कोई यहाँ पर there will be some over smart people who will say, sir, why are you first trying to add all the small numbers, sir? Why are you trying to add all the small numbers, sir? Why for a particular index I, why can't I try with some bigger numbers or something? Well, it's a common sense, bro. Bigger number you will fail in the first move only. Okay, so first greedily what I will try to do is make all of them 0, the smaller ones, and they will surely get defeated, and take all their sums and make a big updated sum, then fight with this. So guys, this algorithm will run in O of n time per index. O of n time per index, you know the solution, right? What to do? Sort the array for each index, calculate the left sum, then start fighting next to next index, next to next index, till the last index. So guys, everyone react with emojis now if this is clear to all of them. Okay, thank you. So guys, this is the, and keep on doing till y comma b of n. If you are able to complete, complete the process, you win. So guys, what will be the final term complexity? O of n per index, which means total time complexity is O of n square. So see, n log n plus n square. So can you see, even after applying so much brain, you could not get efficient solution. That's the beauty of Amazon. So everyone tell me guys, what is the final time complexity? Quickly tell in the Google chat guys, quickly. N square. Okay, okay, great job. So you guys understood this. Everyone react with emojis if everyone understood, everyone enjoyed, and they promise me that they will be able to write the n log n plus n square solution. So hello guys, with the name of God Ram Ram, let's go towards the brilliant optimization. We sort the array guys, but we will sort the array in array of pairs. Okay, so initially, let's say if your array is looking like this, let's say your array is looking like this: 3, 2, 1. This is index 1, index 2, index 3. So you can make a array of pairs, like at the you can say that, yeah, this number 3 is having index 1, this number 2 is having index 2, and this number 1 is having index 3. Now when you sort, now you only sort according to the first number of each pair. So the sorted array, the sorted part will look like 1, 2, 3, but their indice information will be preserved. We will still remember that originally the one guy was having index 3, second guy was having index 2, and third, the number 3 was having index 1. Why am I preserving this information? It will be needed later. It will be needed later because after, let's say I have sorted this array, let's say I come to know that 7 is a good number, but what is the index of 7? You cannot say n minus 1 is the answer. No. Because the original index of 7 was something else in the original array. So you need to save the indices also. So make a array of pairs. On the left hand side, the actual a of I value, and on the right hand side, the actual index. Okay. So these things are assumed. Now let's assume we have sorted the array. And now we will assume that n minus 1, n minus 2 only. Okay. So guys, the brilliant trick is, let's say you have this array. Okay. You have sorted it. You know that the last guy is bigger than equal to the second last guy, greater than equal to till the first guy. Now, if you try to solve this problem from the last indices, it easily gets solved automatically. N is always a good index. N is always good. You know that. You know that it will always win. For n minus 1, guys, for n minus 1, for this guy, what will you do? You just need to know the sum of this much part, right? Sum of this much part from 0 to n minus 2 can be known in O of 1 time using prefix sum method. So if you are watching this video, I assume you know the prefix sum method, or else I will, don't worry, I will attach some, prerequisite videos for you. Okay. You can always do this, my premium warm up DSA course for free. So like whenever someone joins the program, I make them do this warm up course. This is freely available. You can do it. You will be able to solve, like, you will be having the basic understanding for all the OA and CB problems if you do this course. I will link it. Okay. So let's say you calculate this sum using prefix sum in O of 1 time. Okay. You know this sum. You know the sum of these numbers. Okay. So what will be the updated power and energy you have? What will be the updated sum you have? The new sum. You are trying to check if n minus 1 index can be the last man standing. So how will you know if it can be the last man standing? This guy is going to attack all the guys smaller than them. It will always win. So the final power it will have is sum of all numbers from 0 till n minus 2 plus the current value b of n minus 1. So 1 plus 1 plus 4 plus 5 plus 6 plus 7, okay, is the energy. Now if this energy is greater than equal to 8, if the new sum is greater than equal to 8, new sum is what? Sum of all numbers from 0 to n minus 2 plus b of n minus 1. If this is greater than equal to 8, then you can say that n minus 1 is also a good index. You can say that the number at n minus 1, you can say that b of n minus 1 is a good guy actually. Okay. Then you can search what was its original index, but you can say that yes, this 7 is a good guy. Okay. So you have calculated the answer for n in O of 1 time, because you know n is always the best. N minus 1 also is calculated in O of 1 time. But how will you calculate the answer for n minus 2? See, for n minus 1, we can know the sum from 1 index 1 to index n minus 2 in O of 1 using prefix sum array. Now do the updated sum from 1 to n minus 2 plus b of n minus 1. I wrote here sum from 0 to n minus 2. You can write here sum from index 1 to n minus 2, because we are using 1 based indexing. Okay. So guys, we write the updated sum. This was very important statement I did not show you. Please focus on it. Updated sum as sum of numbers from 1 to n minus 2 plus the b of n minus 1, because you're trying to check for n minus 1, the first equation. Now, if this sum is greater than equal to b of n minus b of n, you can just store that yes, n minus 1 is a good index. How will you check for n minus 2? For n minus 2, what will be my new sum? My new sum will be sum of all numbers from 1 till n minus 3. Sum of all numbers from 1 till n minus 3. Okay? Plus the current number n minus 2. So guys, if this new sum is greater than equal to 7, greater than equal to b of n minus 1, what is going to happen? The fight has not ended. This sum is greater than equal to 7 means yes, this 6 was able to beat this 7, but in afterwards it had to beat 8 also, right? If the new sum is greater than equal to b of n minus 1, it means what? It means that n minus 2 was able to beat. It was able to beat n minus 1. Now what will happen? Again the value of n minus 1 will be added, right? Now the new sum will be what? Now you will do new sum equal to new sum plus b of n minus 1, because you were able to 6 plus 5 plus 4 plus 1 plus 1 is greater than equal to 7. So we defeated it. Now 7 is also added to us. Now this much, all the numbers from 1 to n minus 1 are our elements, and we will check can these beat 8. But you don't need to check it, guys. Why? Because now the new sum is nothing but new sum plus b of n minus 1. This is nothing but same as the new sum. When you are trying to calculate the new sum for index n minus 1, when you are trying to check if n minus 1 is the answer, what was the new sum? Sum of all numbers till n minus 1, right? And you already know if this is greater than equal to 8 or not, because if n minus 1 is a good index, if n minus 1 is good index, it means that sum of all elements from 1 to n minus 1 is already greater than equal to b of n. So you don't need to do the next fight. You just need to check, can the sixth guy beat seventh guy? If yes, just check, is 7 a good guy or not? If 7 is a good guy means when the situation comes to 7, 7 will always be able to beat 8. So guys, such a brilliant optimization. Is that for n minus 2, the updated sum is this. Now you just check, is this greater than equal to b of n minus 1? Okay, if yes, then then if yes, then the new updated sum will be sum of numbers from 1 to n minus 2, which is same as equation 1, which is same as the updated sum when you calculate it for the first time for index n minus 1. Now you already know for index n minus 1 if this updated sum was able to beat n or not. So no need to check the full journey again. While I do not need to check what happens after this, because this is same as checking if n minus 1 is good or not, and we already know that. So from the equation 2, if the current updated sum is greater than equal to b of n minus 1 and n minus 1 is a good index, then n minus 2 is also a good index, and O of 1 per index is solve the problem in n log n plus n. So first you sort the array, and then you travel from the end, and each index will be solved in O of one time. So if I make a big array, like many for the hashing and DB problems, I always try to show it to you, in the, when you used to study physics for JE, they always used to say, right, that for the differentiation integration, assume a very big surface, like, right, and then infinitesimally smaller element here. So let's say a very big array is there. This is index I. You are traveling from, backwards till index I. How will you know if this is good or not? So if the updated sum, what will be the updated sum, guys? The updated sum here will be sum of all numbers from index 1 to I minus 1, which you can calculate in O of 1 time using prefix sum, plus the current element b of I. So if this much sum is greater than equal to the element which is at location I plus 1, it means that yes, this I can beat this guy. But now how will you know if this journey can go ahead, if these guys can all beat till the nth guy? How will you know? Just need to check if this is true and I plus 1 should be a good guy. I plus 1 is a good guy or not, you already know, because you must have calculated this now before coming to I. So guys, if this sum is greater than equal to I plus 1 and I plus 1 is a good guy. I plus 1 is a good guy means what? I plus 1 can beat all the guys till n somehow. If both these situations are valid, it means I is also a good guy. So that's it, guys. The problem has been solved with the name of God, Ram Ram. Okay, the C++ Java Python implementation will come very soon here. Okay, Ram Ram.